Hi guys, let's do remove all adjacent duplicates in string. We're given a string S consisting of lowercase English letters. A duplicate removal consists of choosing two adjacent and equal letters and removing them. And we repeatedly make duplicate removals on S until we no longer can. And they want us to return the final string after all such duplicate removals have been made. It can be proven that the answer is unique. So in our examples, we have this input string and we output CA because basically, so we see that in this string we have two duplicate B's side by side here, so we can delete that. And then we see that there's two duplicate A's side by side, so we can delete that. And then we're left with CA, which is our output. And in example 2, we have this string, and we can see that in this string we have two X's here side by side, so we delete that. Then we have duplicate Z's, so we delete that. And then we're just left with AY, which is our output. So to do this problem, we can loop through our input string. And for every character, we can check if it's a duplicate or not by pushing every non-duplicate character onto a stack. So if our stack, we can create our stack, and then so when we're at index 0, we can check the character here, which is A. And do we have an A at the top of our stack? No, because our stack is empty. So we push A onto our stack. Then at index 1, we check if there's a Z at the top of our stack, and there's not, so we push a Z. Then at index 2, we check if we have an X at the top of our stack, and we do not, so we're going to push that X to the top of our stack. And then at index 3, we're going to check if, since there's another X, we're going to check if there's an X at the top of our stack, and there is. So we're going to remove this X and continue along the string. So at index 4, we're going to check if we have a Z at the top of our stack, and we do. So we can remove this Z. And then at index 5, we check if we have a Y at the top of our stack, and we do not. So we're going to add a Y. And now we're at the end of our string. So all of these characters that are in the stack are what we want in our output string, right? So instead of using an actual stack, we can actually just use a string builder, because that way we can just add them directly into the string. So I'll show you again with example 1 so that we can go through this again, but like without it being redundant, you know? Okay, here's the thing. So if we have this, then in order to convert it into a string, because remember that a stack is LIFO, which is last in, first out. So the last character that we push is always going to be the first one that we can take out. And so if we just converted this stack into a string, then the last character would have to go first. So it would essentially be in reverse order and end up like this, which is not what we want. So you're going to have to like convert it into a string and then reverse the string, and that's like a lot of work. So I'm going to show you how we can do it with the string builder instead, because then we don't need to do all that like conversion and reversal and stuff like that. So when we loop through this string S, we check if we have an A in our string builder at the last character, and we do not. So we're going to add an A. Then at index 1, we're going to check if we have a B at the end of our string builder, and we don't, so we put a B. Then at index 2, we check for a B, and we do, so we remove this B. Then at index 3, we check if we have an A, we do, so we remove this A. Then at index 4, we check if we have a C, and we don't, so we add C. At index 5, we check for an A, and we do not have an A, so we add the A. And then we just end up with this string that we can just directly return C, because that's the output. So yeah, the reason why we use a string builder as well instead of just a string is because in Java, strings are immutable. So every time you create a new string, every time you modify the string, you're basically actually creating a new string, which is a terrible runtime. So string builders are mutable, which means that we have a much better runtime because we can just directly modify it instead of creating a new string builder every time like we would have to with the string. Now the only thing with this is you're just going to return the string builder dot to string at the end, which that's fine. So we're just going to do that. And one more thing. So for string builder, so the reason we can use this as a stack is because for stacks, you can really use whatever you want. Like it doesn't have to be an actual stack. Like for stacks, it's more just about how you actually implement it. So the main thing is just that when you remove and add, you can only do that at the end of the stack. You can't add or remove anything that's not at the last character or whatever of the stack, you know? So, okay, we're going to initialize our string builder. And then we're going to loop through our string. Now we're just gonna do that, assign it to character C so we don't have to keep calling char at. And then for each character, we're going to check, well, first of all, okay, if our string builder is empty, like if there's nothing in here, then we can just directly add that character onto our string builder. So if our length is 0, then it's empty, and we can just add that. And so, yeah, also keep in mind the methods for string builder are a little bit different than string, so I would refresh those. Okay, and then if it's not empty, then we need to check if we have the matching character at the last index of our string builder. If we do, we remove it. If we don't, then we add this character, which would be C. So we can assign a character called top to the last character in our string builder, which would be at index of length -1. And if this character top equals C, which is the current character that we're at, that means we have a duplicate letter. So we can remove that from our stack or our string builder. So delete char at, and we're going to delete the last character. So if not, so they're not the same character, then we want to add our current character, which is C, onto our string builder. So we'll just append. Okay, and then we're going to do this for the entirety of our input string. And once we're done with that, then we are just going to return a string of our string builder. Okay, and then our time complexity is O of n, where n is the number of characters in our string s, because, so if we look in the code, we only have one for loop here, and in this for loop, we are basically traversing through each, like visiting every single character in the string. So that is why it's O of n. And then our space complexity is O of n as well, because we need to add each, well, worst case, okay, if there's no characters to be deleted, then we add every single character onto our stack or string builder. And so that would be O of n, because we're adding every single character. And we have that in the string builder here as well. And then we also return it as a string, which is also O of n, but O of n plus O of n is O of n. So that's it for this problem. Thank you guys for watching, and let me know what I should do next. Bye.